All right. Hi, everyone, and welcome to Science Friday Mission Control Live. I am Sandy, the Sci-Fi Education Program Manager, joining you today from Northwest New Jersey. Thank you so much for joining us, no matter where you are. Speaking of which, I really want to know, where are you joining us from today? If you're signed in to your YouTube account, you can actually join us in the chat to the right side or below this video and let us know where you're watching from today. Uh, if you don't know us, Science Friday is your one-stop shop for reliable and relatable science news. We're really well known for our weekly science radio show, broadcast every week on, of course, Friday at 2 p.m. Eastern. You can listen to us live each week on your local radio station or by visiting us at sciencefriday.com and clicking the listen banner right on top of the page. But of course, we do a lot more. When you visit our page, you'll see a variety of articles and educational activities and community experiences for those who love STEM. So be sure to check out that website. I'm really glad you joined us today for Down to Earth Mission Control Live. We have an amazing group of experts here for you today. We'll be hosting these events every week, all month long. And we're also sharing fun, do-it-yourself design challenges on our website each week. So if you want to see all the cool stuff that's happening, just go to sciencefriday.com/down-to-earth. There's the website. Feel free to check it out as we settle in, take a look at last week's activity. There's a lot of good stuff there for you. Now, before we get started, I have a couple of reminders. Science Friday is committed to providing a welcoming and harassment-free environment for all members of all ethnicities, ages, genders, sexual orientations, physical abilities, national origins, beliefs, and any other dimension of diversity. And since we believe in providing clear expectations, I am a teacher, it is, as a necessary part of our respectful community, I'm going to just go over the basics. And hi, Michelle from Texas. So, be supportive and respectful when speaking with one another or asking questions in the chat. Share generously and listen closely. You can add your thoughts whenever you want in the chat, even if they aren't strictly questions for our guests. Try to stay on topic as we are here to discuss this week's topic of space science and the International Space Station and closely related topics. And we do reserve the right to remove anyone who engages in demeaning, discriminatory, or harassing behavior. We want everybody to be able to have fun today. All right, great. Thanks for sticking with me. So with that, it is now time to get started with our show today. Are we ready, or who are we starting with today, Diana? Okay, we are great to go. Welcome, Cady Coleman. Cady Coleman is a former NASA astronaut and retired U.S. Air Force colonel with more than 180 days in space accumulated during 2 space shuttle missions and a 6-month expedition to the International Space Station as the lead robotics and lead science officer. She is also a popular public speaker and media consultant, and she serves as a research affiliate to the MIT's Media Lab. She's a regular contributor for Space Exploration News and co-hosted Arizona State University's Mission Interplanetary podcast. Cady serves on several boards, including the Smithsonian National Museum of Natural History, the Greenfield Community College, and the ISS National Lab Education Advisory Group, who are our funders for this project. Her book, Sharing Space, An Astronaut's Guide to Mission, Wonder, and Making Change, about her NASA experiences and insights she gained as an astronaut, was just published by Penguin, and it's fantastic. You can actually hear Cady talking all about the book on Science Friday from a couple weeks ago. Cady, thank you so much for being here, and welcome.
Well, thank you, and thanks to everyone for their help in problem solving in real time to get me on the screen here. I really appreciate that.
That's great. Yeah, I mean, we have a wonderful crew, and I do just want to give a thumbs up to Diana, who is in the background making all this work, folks. So please do go ahead and introduce yourselves in the chat. And Cady, why don't you tell us a little bit about the work that you do? Because I think it might be a lot for people to visualize.
Well, and I'd love to show slides when you think it's okay to do, but you heard that long, not, I don't mean too long, Sandy, but whenever you hear a biography like that, I think it makes it sound like it must be somebody who always knew exactly which way to turn when faced with a fork in the road, left or right, or study this or go here. And I think if you ask any of my other colleagues and me as well, it's not, we're actually real people just like you, trying to make decisions with the best information that we have. And often that comes from science. So I'm really excited about being a scientist. And which I was originally a scientist before I was an astronaut, a chemist. And I liked the kind of chemistry where you use chemistry to make materials that make a difference in people's lives. And I really loved that. And then I was in a very good place and right time when NASA was building the space station in order to do science experiments. And so I thought I would tell you a little bit about my shuttle stuff and share slides if this is the right time to do that.
I think we're still uploading those slides. So maybe you could just tell us about what kinds of research does happen on the International Space Station. I think people don't realize it's really a science lab. It's not just a cool place to go in space.
And in fact, around our country, we have a number of national laboratories, and the space station, even though it's not on Earth, is one of them. And what's interesting to me, you'll see pictures of these things, but actually, I think it helps if I almost explain them ahead of time. Is with people think about us being in space and we're floating around. My hair, just like on the cover of my book, my hair is very big and just really without gravity. A lot of things change, and I know we're interested in doing science here and doing science, as citizens and citizens of planet Earth. And so we think about variables. What is it that we could change where we could understand or measure better? And one of my favorite examples of that is liquids. Like liquids are really important in how they behave for everything from every process that involves flow through a pipe in a factory to make something, or a river or an ocean, or looking at erosion, or looking at the interaction of pollution, or even, what about the flow in our pipes, in our veins and arteries? And in all of those things, we understand a lot about flow, except right at the wall, like in a pipe. In a pipe, we don't understand what happens, like maybe right at the wall, and where the liquids come in contact with the wall. And so, and you can even see this. And if you have chemistry class, sometimes you make your measurements with those cylinders that are long and tall, and it has a meniscus. And what's happening in that meniscus, where it's sort of climbing up the sides, and that happens in your glass too. Like if you have a glass of milk or whatever, you can actually see on the edge, it kind of climbs up there. And it's because those liquid molecules, whether they are milk or oil or whatever, they really like themselves and each other. They really like to be together, but they also are attracted to go up the wall of that container. And when we study them down here on Earth, well, we see the end of that battle pretty quickly because gravity wins. These forces of climbing up the wall, they're tiny compared to gravity, which is like enormous. And I mean enormous. So going to space, we take away this enormous variable, and all of a sudden, that, like, just like you see sometimes on your car, when your car is really clean, all the little water drops are nice and brown and just sitting up, and on a dirty car, home spread out. So you see that a little bit down here on Earth. Well, up in space, we take away gravity, we get to see exactly what liquids want to do. And so we get to study things that we can't study down here. And another thing that we look at in that way is combustion. And that's where, with combustion, combustion is important to understand pollution, to understand how to heat, our buildings and places that we live and work in an efficient way that is as sustainable as we can make it. And combustion's a tough thing to study because if you think about your basic candle flame, here's the candle flame, it looks, big at the bottom, kind of pointy. And what's happening is that as something burns in the candle flame, as the wick burns, then in the fuel is the wax there, right? Well, there's gases given off, and those gases are lighter and they rise just like a hot air balloon goes up. Well, up in space, now without much gravity, now those lighter gases, doesn't matter. Lighter stuff, heavier stuff, no rising. So our flames are kind of more spherical. And it takes longer, like in a real candle flame on Earth, or not, it's still real in space, but in a candle flame on Earth, that when those lighter gases rise, new fuel rushes in, and it happens so fast, we have to make measurements in less than a second. In fact, in a millisecond, we have to make measurements that determine the slope of a line. And up in space, those same measurements that have to be made in less than a second down here on Earth, we make those same measurements over 30 or 40 seconds. It's so long. And that means we can have a lot of data points, or even we can see that the data points are like everywhere, and it's actually not very regular. So we use math and science. What the basic principle is, let's take something that space gives us because gravity's not there, and let's learn and measure differently.
This brings me to kind of another question I had for you. It sounds like living in space is a lot different just because of that microgravity environment. So, what surprised you the most about living in space, and how was it different from Earth?
Most of all, how much I loved it. And I know that we have our friends Sunny Williams and Butch. Butch's last name just ran out of my head, but I know him too. And these are our two astronauts that's been in the news a lot, the two stranded astronauts. And as their friend and colleague, I am telling you that we train for this. We spend a long time getting ready for each mission, and it's because some of the science that I just talked to you about, the feeling and what you're doing as citizen scientists, like I think we have actually the same feeling when you collect a piece of data and it counts, it matters. Because let's say you're counting birds around the planet, around in your backyard, you're counting birds on a certain day. That happens with some studies on birds, and you made a measurement that counts, that matters. Well, that's what we feel like up there, because we know we're doing science that can't be done on Earth, and it matters. And so the fact that Sunny and Butch get to do that, not just for 8 days, but for 8 months, and especially because they're experienced astronauts like me, they've lived there before, and it takes about a month to get good at doing science up there. Because even though what's magic about it is that everything floats around, it also means that it's like you let something go and it's just gone. I found someone's pocket knife after 3 years. It had been
Wow.
gone for 3 years. And so if you lose something, it can really be gone. And so I just think that's a long way to say I think Sunny and Butch are really happy up there, for the same reason that it's magical. And I liked living up there. It was hard on me because I am actually kind of good at losing things. Um, but mostly
Moonfish just
I like the flying because I'm not the most graceful person, and I'll just like I won't pull it out. But if you were to pull a hair from your head and then use it, stretch it out, and then push against like a railing in the space station, if you push hard, you'll break that one single hair from your head. But if you push gently, it is going to push you like all the way across the space station
Oh, and
until
that brings
you
us.
hit something.
We have a question from Moonfish. She wants to know, was it like swimming in space? And it sounds like not quite.
Well, it is pretty hard to swim in space. And you'll see us sometimes kind of going, like we're in the middle of the module where we can't reach maybe either side and there's nobody else around. And, there is air up there. So when I push my hand like this, there is resistance. And so eventually I can get myself turned around. But, down here, if you give yourself a push, you're going to go somewhere. But if you don't have anything to push against, and that's the principle of like spacewalking. If they're using both hands, that means that their feet are sort of tucked in somewhere. So it gives them the leverage to really do something. Because otherwise, as soon as I go like towards the screen and push the screen, like I'm not going to be able to use my screwdriver like this and actually screw something in, because as soon as I push, it's going to push me away. So you got to figure out you always have to be holding on to something or anchor your feet.
So, another question I had, and you talked about this a little bit when you were on the show, how the living on the space station changed your view of our world. And I know that you said that it was a beautiful experience, but how did just seeing everything from above change how you think about all of us on Earth?
For me, it was a really optimistic thing because I don't know. I think of people, and everybody but the people living on our space station and the people living on the Chinese space station. And those are the only two space stations up there yet. Okay. More are coming, I'm sure. But everybody else, every other human is down on Earth. And that means that if you're trying to solve a problem and you need an engineer and a scientist and an artist and somebody that's really good at telling the stories through art, but also through words, and maybe let's say you need not just a scientist, but I know I'm using a lot of words to say that most of our problems are pretty hard these days, and we need a lot of different a lot of different disciplines together. You don't just need a scientist. You know, like let's say, I mean, you need somebody that's really an expert at the measurement that you're trying to make, and then you need somebody who understands the problem that you're doing. And so when I look from above, I see that you know, everybody is down there except for the 10 of us, right? And so I see. I just dove. There's an expert here, an expert here. It's almost like in our chat right now, where you've been giving science or you've been giving experiment sort of challenges every week, right? And the people who are working on them, they don't actually know each other, most of them. And the only place they really meet is at this challenge. They could be living anywhere in Earth. And in fact, it's best for the challenge if the data points are coming from a large different number of places. So that's the view I have, is that, I don't know, home is just bigger than we thought and yet smaller too, because when we need to, we can find each other and work together. And I'll be a little faster with my answers.
No, I'm just letting everybody know that we do have an online community for them to be able to actually share their thoughts and communicate with one another, which is, I think, something that's really special because as you're exploring and learning new things, that's really fun. We are getting close to our end of our time already. So before we move on to our design activity, I do want to ask you one last thing.
Sure.
And that's for our young scientists that aspire maybe to become an astronaut or a scientist and live in space, what advice would you give them?
I would say stay curious and realize that your ideas are important. And it doesn't mean that you have to have an idea that you think will change the world, because the world changes with lots of smaller ideas that sort of coalesce and get talked about between different people and then become something that like it has to sort of grow up and become a little bit bigger. And that happens when it gets discussed and teams work on it. And so I would say stay curious and realize that when you kind of go, I wonder how that works, you're probably wondering in a different way than anybody else. And your viewpoint is really, really important. So don't be put off or think that just because you're not in what you think of as an expert at that, realize that sometimes the person that looks at it from the outside and knows nothing about that field, but just kind of takes an outside look, can have the most valuable perspective. And plus,
That
you can always learn about stuff.
I love that. That is amazing. And that is a perfect moment to bring on our friend Tiffany Lucy, who is actually our educator that designed our activity today. So remember, everybody, if you have any other questions, you can drop them in the comments and we'll continue answering them on Community Lab even after we're done today. But I am going to go ahead and bring Tiffany in, I think. I'm going to try. Okay, and sorry, I don't have my usual
I see
helper.
Tiffany. I see
Hi,
Tiffany.
Hey,
Tiffany.
how are you? I'm so excited to be here.
So let me introduce you to Tiffany Lucy. She is the supervisor of educational technology at Toms River Regional Schools, where she links curriculum and instruction and identifies student needs while consistently seeking alternative sources of funding. As a former Teacher of the Year for mathematics and computer science, she has become known for her interdisciplinary maker approach to learning. And we have a really exciting challenge for you to try this week, thanks to Tiffany and all of her creativity. So, Tiffany, why don't you share with us what you have created? And I'm just going to make a little space on the screen for that and add this to the stage. And there we go. Oh, sorry.
That's quite all right. I'm so excited. This has been such a great opportunity to put together this challenge. Our mission this week is Mission Sensor Watch, Cool Your Community. And you can find these resources, of course, on sciencefriday.com/down-to-earth. So as you know, the International Space Station is hurtling around the Earth as we speak with these astronauts on it. And on the edge of one of these arms is this thing called eco stress. And that's going to be our focus today. The eco stress really has a scan mirror and it's picking up data with something like a camera lens. And the scanner mirror is swinging back and forth and sending the information back to us as data and imaging. So we can look at how we can visualize heat data, which can help you better understand climate change and the impact of urbanization and heat islands on your communities. If you look at these images over time, like here, between 2019 and 2020, you can see how construction and development, that urbanization creates more heat islands and reduces the coverage of the surface with plants. You can see that the red is really where that heat is, and that the cooler areas, there are fewer and fewer over time. So, what we're going to have you do for your challenge this week is to record the ambient air temperature recorded by a weather app for your area on the sensor watch chart. So, there's going to be a handout that you'll be able to print, and then you'll be able to make all of your recordings of your thermometer as you go through it. So you'll go ahead and you'll take the temperature outside, you'll make some predictions. Of course, you're going to watch for cars and have adult supervision for this. And then you're going to make predictions about what will the temperature be on the pavement. Is it going to be hotter or cooler than the air that's all around you, right? Then you're going to move it over after a few minutes over to a mulched or a plant bed. Do you think that's going to be hotter or cooler? So once we make that prediction, we're going to wait and we're going to find out. Right? And then maybe you even want to try some other locations that are unique to where you live. Then you're going to take Google Earth and you'll navigate out to a map. And I chose here at Tom's River Schools because that's where I am. And so I wanted to make that information look like I think it might look from space. So I took my local map on Google Earth. And when you look, you can see along these roads that there are far fewer green areas, and then it's really dense over here. And so you can make a drawing like that. So you can take a nice red marker or some crayons, and then you can show where your downtown business district is. You can see there's some other big stuff out here, right? And then you think, well, maybe you want to add some blue to make it cooler, right? That's the water. And then you can see where we have these nice green grassy areas, that's where really all the moisture is. And what the eco stress is trying to do is measure the moisture on the earth and see how much is really covered by plant material so that we can see the impact of urbanization and try and come up with some solutions. So finally, what you'll do is come up with some solutions, and I'll give you some great models from the EPA and from NASA that really look at this and look at some strategies to look at protecting our environments and adding some green space to cool off these heat islands so that we can make a better and more sustainable Earth. So I hope that you're as excited as I am. If you have any questions, please put them in the chat, and I look forward to seeing what you make.
And I forgot to unmute myself. Thank you so much, Tiffany. I'm really excited. Before we wrap up today, remember, any last minute questions, let's get those into the chat. But I want to thank everybody for attending today. I want to thank our amazing guests, Cady Coleman and Tiffany Lucy. I want to remind you to join us over on Science Friday Down to Earth. Check out the website for fun activities and more about next week's event. Before we go, though, I wanted to give both Cady and Tiffany a moment. If you wanted to just share any final thoughts with our young audience. Cady, why don't we start with you?
Well, mostly I'm intrigued with the challenge that Tiffany has put out there where, I mean, I live up here in Massachusetts and people are talking about, oh, is this fall look like the best, or the trees look a little bit different? Did the leaves come off first? Or, in places where temperature really matters. And then I thought about the hurricane place and, with all that water, will the ground stay cooler longer? And I just think there's some really interesting questions all around us in our community. In a way, people are always talking about the weather, and I think it's because that's the ocean that we swim in. Really is the temperature, and thinking about the temperature of what's really around us and predicting it. I find myself really intrigued, and so I'm excited to hear the results.
That's wonderful. Yeah, I am really curious to see what people, because I'm in a rural area, which is very different from urban areas, but we still have heat islands.
Sure.
They're everywhere. So anywhere that we have made changes to the earth. So I'm curious to see what people discover. And Tiffany, is there anything that you'd like to leave our learners with?
I love Katie's idea of really stay curious, and really think about other ways of expressing yourself through this data. I think that integrating the arts into the sciences and allowing students to find other ways to express what they are experiencing around them, I think makes a big difference in people's understanding of it, as well as students' ability to really connect with content. So I think that it's important as educators that we really focus on um, making learning as accessible as possible and as much fun as possible, and really sharing our joy and passion. And I love NASA and all that you guys do. And this was kind of a perfect scenario for me. So thank you so much for this opportunity.
Wow, that is fantastic. Thank you both for joining us. Thank you for inspiring our next generation of astronauts and scientists and thinkers and creators and artists. I really appreciate it. I hope to see all of your suggestions and all of your creations in our community lab. And until next week, thank you, everybody. Stay down to earth, and we will see you again soon. All right, goodbye.